Network serial course from Alibaba Cloud. So for these serial courses, we will have a comprehensive knowledge about the networks. So today is the first class, and today's topic is about the network fundamentals. So we get started. Before we learn about the networks, the first thing that we should know is the ISO model. So let's go into the first section and learn about what is ISO model. Okay, so for OSI model, the full name for OSI is Open System Interconnection, and we can see that OSI model is the basis of the network connection in the current time. And OSI model is aimed to standardize the communication between different systems. Because as we know, for different systems, each of the system has its own protocol to make communication, right? So we need a standard to make it possible to communicate between different systems. And for OSI model, 7 layers of the data transmission has been defined in it, and roughly we can define the 7 layers into data flow layer and the application layer. We can see the picture on the right. From the bottom is the physical layer, and is the data link layer, network layer, and the transport layer. These 4 layers belong to the data flow layers. And in the upper layer is the application layers. It includes session layer, presentation layer, and the application layer. Okay, so in the next we will know that what is the detail in each of the layers. Okay, so we came to the next page. Okay, so for this page we can see that the lowest layer is the physical layer. Actually, we can say that the physical layer is the lowest layer in the OSI mode, and this layer is responsible for the wiring and the electric signal transmission. And the upper layer is the data link layer. In this layer, all the data is transferred in frames. And there is one thing that we should familiar with is the MAC address, right? In the data link layer, the MAC address is used for location. Okay, so the upper layer is the network layer. So for this layer, the data is transported in packages. And there is also one thing that we should familiar with is the IP address, right? In this layer, the IP address is used to location, and the package will be transported according to the routing information. Okay, and the upper layer is the transport layer. For this layer, there is one thing that we should familiar is the TCP/IP protocol, right? And especially for TCP, it will ensure the data transport reliability and flow control. And for this layer, it is responsible to make a reliable and stable connection between systems. Then we came to the application layers. So for this layer, the first layer is the session layer. In this layer, it allows different machines to establish sessions between them. So as we know that if we have visiting some website and there will be a session has been established between our client and the server operating system, right? So this is the thing that has been done in this layer. Okay, and for the upper layer is the presentation layer, and this layer is responsible for the presentation of the data. Like if we want to show the picture, we can use the JPEG, right? And if we want to show the videos, we can use the MP4 or AVI. And if we want to show some text, and we can use the ASCII code, right? And this is what has been done in this layer. And the highest layer is the application layer. So for this layer is used by the applications. And this layer is end application programs or services used by end application programs. Like if we want to show the the HTTP or some website, we can use the HTTP protocol. If we want to connect some operating system, we can use the Telnet or SSH. So this is what this layer has been done. Okay, so this is all the layers for the OSI model. Okay, so for this page, we're going to talk about the data encapsulating. The first thing that we should know is that data can only be transferred in one layer with corresponding package header. For example, if your data want to be transferred in the data link layer, your data should be have MAC header. And if your data want to be transferred in the transport layer, you should have the TCP header to be recognized by the corresponding protocol. That's why we say that the data should have the corresponding package header in each of the network layer. And the second thing we should know is that no matter what data you have, basically the data is transferred in the electric signal format, right? Basically. And so we can say that all the data is transferred in the physical layer after all. So we should know that in the application layer, if your data need to be transferred, your data is required to be encapsulated layer by layer from up to bottom before sending out in order to transfer in the physical layer. And that's the thing that we should clear. Okay, after we have known what is data encapsulating, we should know data de-encapsulating. As we know that the data has been transferred to the destination, and the application on the destination side will need to use the data, right? But we should know that the application will not recognize the data that has been added some headers information, that right? So this is not the original data. So after the data has arrived at the destination, all the headers, the IP headers, the TCP headers will be removed from the bottom to top. First is the MAC and the LLC and the IP headers and the TCP headers, and then we can get the original data that can be recognized by the application. And that's why we say that the data can only be recognized by the target application after all the data headers has been de-encapsulated. So we can just say the data de-encapsulated is the reverse procedure of the data encapsulating. Okay, after we have learned about the OSI model and also something about the data encapsulating and the de-encapsulating, so for the second section, we are going to learn about some network protocols. In this section, we will have to learn some worldwide used network protocols. So let's get started. The first protocol that we are going to learn about is the ARP. And for the ARP, the full name is Address Resolution Protocol. And it is used to discover MAC address according to the IP address. Because even though that normally we are doing the communication with the IP address, right? But basically in the layer 2 network, it is using the MAC address to find with each other. So that's why we need to know the MAC address according to the IP address. And for ARP, one thing we should know that it works in OSI data link layer because data link layer is using the MAC address to do location. This is what we should know about the ARP protocol. Okay, so the second protocol that we should know is the TCP protocol. The full name for TCP protocol is the Transmission Control Protocol. This protocol is worked in OSI transport layer. In this layer is the fourth layer. So what we should know about TCP protocol is that this protocol is aimed to provide a reliable, ordered, error-checked data transferring via IP network, which means if you are using TCP protocol, you don't have to worry about whether the data has been transferred successfully or not, whether the data is lost or not. You don't have to worry about this one, because TCP protocol will help you to do this kind of checking and verifying. So this is what TCP works. And in the TCP protocol, it is using the IP plus port to define a communication endpoint. If you want to find some place in the TCP protocol, and you will have the IP address and the port. And the last thing we should know that in the TCP protocol, connection must be established in a 3 steps handshake process before entering the data transfer phase, which means the data is not directly start to transferring. Before the data transferring, it will have a 3 steps of handshake process. And after this handshake process, the TCP will verify whether the connection has been established successfully. After this, the data will start to transfer. This is how TCP protocol works. Okay, the next protocol that we'd like to introduce you is the HTTP protocol. The full name for HTTP protocol is the Hypertext Transfer Protocol. And as we know that HTTP protocol is working in OSI application layer. This is the highest layer in the OSI mode. And HTTP protocol is aimed to exchange or transfer hypertext. Because as we know, hypertext is actually we can say it's the most widely used information format in the internet, right? So in some degree, we can say that HTTP protocol is the foundation of the data communication for World Wide Web. And when the HTTP protocol is working, it functions as a request and a response protocol in the client-server computing model to achieve information transferring. This is how HTTP protocol works. Okay, after we have learned something about the network protocols, and for the next section, we are going to learn about something is very important, which is the IP address. As we know that normally we are using the IP address to do network communication, right? So let's get started. Okay, I think most of you guys have been very familiar about the IP address format. So here I will have a brief introduction about the IP address. First is that the IP address consists of 4 octets, and for each octet it have 8-byte size number, which ranged from 0 to 255. And for one IP address, it uniquely identifies a host or device in one network. This is something about the IP address. And after we have introduced you the IP address, there must be something that we have to introduce you together with IP address, which is subnet mask. Actually, we can say that the IP address must be combined with subnet mask because subnet mask is used to define the network byte and the host byte of one IP address. Even we can say if one IP address is the same, but if it combined with different subnet mask, then the IP address will be located in different networks. So we should know that from the combination of the IP address and the subnet mask, we can get which network the IP address is located in. That's why we say that the subnet mask is very important to the IP address. And next thing that we should know is that subnet mask can be in format of decimal notation like address format, like sum.sum.sum.sum, or in format of byte number from 1 to 32. For example, if we say that the subnet is in byte of 24 and the address format is 155.155.155.0. Okay, so this is how the subnet mask works. Okay, after we have learned about the IP address and the subnet mask, we should know another concept is the IP address classification. All the IPv4 addresses has been classified into 5 parts. It's class A, B, C, D, and E. And we should know that class A have the most IP addresses, and the class B to C to D to E, the quantity of the IP addresses become less and less. And another thing that we should know is that just the class A and B and C can be used in the host environment, which means you can only configure the IP address in the class A, B, and C on your own host or your own virtual machine, but you cannot use the IP address in the class D and E because these two classes have been reserved in some special condition, like multicast or some other special environment. So this is what the IP address classification is. Okay, so for the IP addresses, there are another thing that we should know is that not all the IP addresses can be transferred in the internet. There are some IP addresses that has been reserved for private usage. Okay, so here we can learn about what is those IP address for private usage. And the first private network segment is the 10 dot segment. This is the class A segment. So this segment is used for internal use in the internal network environment. And the second one is the 182.16.2.31. This class B segment is also used for private. And the last one is the 192.165 segment. This class B segment is also used for private usage. So these three IP address segment is all used for a private network environment, like your own company network or your own enterprise internal network environment. And also there are some special reserved addresses are also not used in the internet. The first one is that the IP address is 169.154 segment, class B segment. This segment is used for automatically private IP addresses use. For example, for sometimes maybe your machine or your server is doing the DHCP, but you cannot require some IP address, and then the IP address in this segment will be assigned to your computer. And the next one is the 100.64 class B segment. So this segment is used for carrier grade native environments. This segment is reserved in the recent years in 2012 this year. Okay, after we have learned something about the logic network knowledge, like IP address or network protocols, and the last part we are going to learn about some hardware knowledges for the networks. So let's get started. Okay, so for the first part is the Ethernet cables, because as we know that if we want to connect different systems, basically in the physical layer we should connect with the cables, right? So in this page we'll learn about something about the Ethernet cables. So here we can say in the worldwide scope there are 3 kinds of network cables that is adopted in the worldwide scope. And for the Cat5, this level of the Ethernet cable can just support 100 megabyte speed. And for category 5E and category 6 can support 1 gigabyte bandwidth. This is the difference between these three Ethernet cables. And for category 6 cables, it has more powerful hardware specification. It has a better quantity of the cable. So actually, we can say that category 6 is the best quantity network cable. And for this page, we have known some Ethernet standard from the 10 base T to the 1000 base ZX. From the top to bottom, the standard become higher and higher, and for each of the standard, it has defined the transmission media, the interface type, the maximum transmission distance, and the speed. Here, roughly, we can say that the fiber channel standard is have a better standard than the category 5 or the RJ45 interface. So we can say that the optical cable have roughly have higher maximum transmission distance and also have higher transmission speed. And for the last part, we can know some hardware vendors in the network scope. Here we can say many famous hardware vendors of the network devices, like for Cisco, for H3C, for Huawei or ZTE. All of them is focused on the routing and the switching devices. And for Juniper and for Checkpoint, both of them is focused on the security devices like firewall. And for F5 and ReadWare, these two companies is focused on the load balancer. Okay, so this is all the things about the network fundamentals. Thank you. Bye-bye. Hey guys, welcome to Network Serial Courses from Alibaba Cloud. Today is the second course, and today's topic is two of the most important concepts in the network scope. They are switching and routing. So let's get started. Okay, so for the first section is what is switching and routing. We will have a brief understanding for switching and routing in this section. Okay, so let's go on. And in the beginning, we should go back to the OSI 7-layer architecture. And when we're talking about switching and routing, we should mention the devices that are related to these two concepts. They are layer 2 switch, layer 3 switch, and router. We are talking about layer 2 switch. It is working in layer 2. And the layer 2 switch only deal with MAC address and no IP addresses. So we can say that the layer 2 switch is the pure layer 2 device. And the next one is that the layer 3 switch. And from the name, we can know that this device is the switch. But it is not only a switch, it has features for routing. And the next device is the router. And for router, we can say that it is the pure layer 3 device. It has full layer 3 features, complete WAN technologies. So this is the devices related to switching and routing. Okay. After we have known the devices related to the layer 2 switching and the layer 3 routing, actually we should know that what's the difference between routing and switching. Here from the picture showing here, we can say some difference between the routing and switching. Like the layer 2 devices, like routers perform routing, and for layer 2 switches, the pure layer 2 switches perform switching. And For routing, the routing will be slower as it is software based. And for switching, it will be faster because switching will use the chipset, and it will we should know that the hardware forwarding is faster than the software, right? And for routing, it is done in layer 3 of OSI model, and for switching is at layer 2. So this is what we have known. And the next one is that for routing, if destination is not known to the router, it will drop the package. But for switching, if the destination is not known, the switch will broadcast the frame to ask in the broadcast domain, and all the devices will check whether it is the destination. This is the difference between the routing and switching. And for routing, it is done in different network, which means routing is used for connecting with different networks. And but for switching, it is used to establish a connection within one network, which means within the broadcast. And for routing, routing is done by using IP address, but for switching, it is done by using MAC address. But for some time, maybe we are communicating within one network with IP address, but basically it is using the MAC address. It will use the ARP protocol to transfer the IP address into the MAC address and do communications. And for routing, the last point is that the protocol data united at layer 3 is packaged, which is different from switching. Switching is using the frame to transport the data. This is all the differences between the routing and switching. And just now we have a brief introduction about the layer 2 switches, layer 3 switches, and the routers. So here we will have a detailed understanding about the devices. And first one is that normally hosts are connected with switches, which are the most widely used layer 2 network devices. Which means for layer 2 devices, not only switches, but also like repeater and some other devices which is working in layer 2 network. And the second one is that switches normally have many ports to connect with hosts. For example, for one switch, maybe it will connect 20 or 50 so many devices in one switches to make the layer 2 connection, because one network within one network there will be many hosts in one layer 2 network. So that's why switches normally have many ports. And when several layer 2 networks need to be connected with each other, the router will be adopted to provide the layer 3 communications, which means that the router is normally have to use to connect with different switches. And so here we can say that there's a point. Router normally have less ports than switches, because the router just connect with the switches. Actually, we should know that the quantity of the switches must be much less than the host, right? So normally the port on the routers is less than the port on the switches. And the last point is that there are some special devices that I have mentioned previously, is the layer 2 switches. For these switches, it is a switch. It can provide the layer 2 communication like in one broadcast domain, but it can also provide layer 3 features like routing. It can make all the layer 2 networks in the switches can communicate with each other. This is what the pure layer 2 switch cannot do. Okay, after we have known something about the switching and routing, and for the second section, we will have a deeper understanding about layer 2 network. There are two important concepts in layer 2 network. They are VLAN and the trunk. So here we will have a deep understanding for them. So let's go on. Okay, so for the first point, we are going to talk about the VLAN. The VLAN full name is Virtual Local Area Network. And for VLAN, it is isolated broadcast domain and the data link layer is the OSI layer 2, which means for different VLAN in layer 2 it is isolated. It cannot communicate with each other in separate VLAN. And for VLAN, it is configured on switches. Means that if you have a switch, you can create many VLANs on the switch, and for each of the VLAN, it is isolated and cannot communicate with each other. So with this feature, normally we will put different VLANs for different application or businesses to do the application isolation in the layer 2 network. And after we have learned the VLAN technology, we have to learn about another technology named trunking. And for trunking, what is trunking? Firstly, we should know that normally the default port mode on the switch is access mode, which means access mode is normally connected with host and can only be configured in one single VLAN. For example, one access mode you can configure in VLAN 1 and another access mode port you can configure on VLAN 2, and for this port for these two ports are located in different VLAN. But there are some special scenarios, like for example, if you want to interconnect with two switches, and for each of the switches, you have configured 3 VLANs on them, and if you are using the access mode port, you should use 3 ports to do the interconnection. If you have more VLANs, you will have to use more cables to do the interconnection. Each of the port is responsible for 1 VLAN. But now if we are using trunk, we can make it possible that achieve multiple VLAN data transferred via one single switch port, which means we can just use one single switch port to transfer all the data in all the VLANs. So this is very useful to simplify the network physical architecture. Okay, after we have learned the layer 2 network features like VLAN and trunking, and here now we'll come to the layer 3 network features. Here I will pick up 2 important concepts in the layer 3 network, is routing and NAT. So let's start. First, let's talk about routing. So what is routing? Here we have a description about routing. When data need to transfer between different networks, routing will be used to find the correct path for each of the networks. So obviously we can understand like routing is tell the package to find the path to the destination, right? And for routing, one thing we should know is the routing table. There will be a routing table on each of the router to store the routing information. So this routing table is just a guider of the network. Once one package comes to the router, and the package will check the routing table and find the next hoop of its destination, of its own destination. This is how the routing table works. And for each route in the routing table, it will show you the next hoop IP address or interface of corresponding destination IP address. For example, the routing table will show you that if you want to go to 182 segment, you should go to the next hoop IP address is what, and if you want to go to 198 segment, you should go to which interface, something like this. And the last part is that the package will find the next hoop IP in the routing table and then go to the next hoop. Then repeat the previous step until reach the destination. Because, for example, if the package has arrived some router, and the router will have shown the package that the next hoop is the next router, and then the package come to the next router, and then the next router also have its own routing table, and then the package will check the routing table again and again, and until it finds its destination. So this is how the router and routing table works. And when we're talking about the routing, there are two things that we must mention, is that the static route and the dynamic route. So let's see from this picture and see that what's the difference between the static route and the dynamic route. So firstly, when talking about static route, we should know that it is using a route that a network administrator entered into the router manually, which means all the routing information should be entered and manually by the administrator, by a human being. But for dynamic route, all the routing information in the route table is automatically generated by the dynamic route protocols like OSPF or BGP, which means you don't. There is not a human being required to maintenance or to generate the routing table. And the second one is that for static route, there is a big advantage is that you can full control the routing information, which means if you are an administrator of the router, you will be very clear about the routing information on the router. But if you are using the dynamic route, you are not very clear about what's the current routing information of the router, because once the network architecture has changed in some moment, the dynamic routing protocol will regenerate the routing table and to do the optimization on the routing information. So if you are administrator of the dynamic route protocol, you will not be very clear about what's the current routing information of the router, which means that you cannot have full control on the routing information on the router. And but for static route, there are also a big disadvantages that if you are using static route, you should design the routing path redundancy by yourself, which means that you should, for each of the route, you should design the backup route or redundancy route to prevent that the single point failure, right? But if you are using the dynamic route, because the routing information in the router is dynamically and automatically generated by the dynamic route protocol, and so you don't have to care about once some single point failure has happened, what will be done. The dynamic route protocol will dynamically change the routing information to make the route always be established, which means that as long as you have redundancy physical connection, the dynamic route protocol can always make sure that the route information is redundant. But for static route, it has a big advantage that the route status is stable. That means the route status will not be changed very frequently, because all the routing information is inputted by the administrator, right? But for dynamic route, the routing status may shaking when the network topology is changed, because every single network topology change will make the whole network recalculate the network status and regenerate the routing table on each of the router. So that's the difference between the static route and the dynamic route. And when we're talking about the route, there are also one thing that we should know is the default route. The default route is the route for all destination IP address, which means the default route is suitable for all the destinations because it has matched all the network segment. But it will be adopted when the package cannot find the corresponding route information in the routing table, which means the default route has the lowest priority. Only if the package cannot find exact corresponding routing information in the routing table, it will use the default route to go to the next hoop. So this is how default route works. Okay, so we come to the next layer 3 network concept. It is NAT. Before we learn about NAT, we should know something about the IP address. Previously, we have introduced you is that IP address have two types, right? One type is the public address, which is registered in the internet, and another type is the private IP address, is used in the internal network, like company network or enterprise network. But there are some scenarios like the host in the private network or in the company network need to visit the IP address on the internet. As we know that the private IP address inside of your company or inside of your network cannot be routed in the public IP address, in the public network on the internet. So we should find a way to make it possible to that the network inside of the company can visit the internet. This technology is NAT. NAT can allow an organization with unregistered private IP address to connect to internet by translating those IP addresses into globally registered IP addresses. Which means that maybe for some host or for some server, when it is inside of your company, it is configured as the private IP address. But when it go outside of your company network, like if the package go outside of your edge firewall or edge router, the IP address of your host will be translated from the private IP address to the public IP address. Then the package can be routed in the internet. So this is how the NAT works. And one more thing is that just now we are talking about the NAT, right? But there are some scenario like maybe you have many hosts inside of your internal network need to visit the internet, but we also know that the internet IP address is expensive, right? And it has limited quantity. So in this scenario, we will have a technology named overlanding. With this technology, is a form of dynamic NAT that map multiple unregistered IP addresses in the internal network to a single registered IP addresses, which means many to one, right? Many internal IP addresses to one public IP address by using different ports. Because for each of the internal IP address, maybe they just need to explode one port or several ports to be visited by the internet. So we don't, for each of the internal IP address, we don't have to configure each of them independent public IP address. It is a waste of resource. So in this scenario, we will use the overlapping technology to map multiple unregistered IP address plus the port to one single registered IP address plus port. And this technology is also known as PAT. Just now we are talking about many advantages of the NAT, but there is also some disadvantages, like sometimes NAT is blamed for IP connectivity problem when there is actually routing information problem, because the NAT will make the IP address changed, right? So when we are doing the routing problem troubleshooting, maybe we don't know that the original IP address has been changed to the some other IP address. This one will make it difficult to do the routing troubleshooting. Okay, so after we have learned everything about the networks, and for the last part, I'd like to show you what is the network architecture on the cloud. So here in this section, I'd like to introduce you the Alibaba Cloud Network Solution, VPC. So let's get started. Okay, so for VPC, the full name is Virtual Private Cloud, which is the dedicated private network established in Alibaba Cloud. And for VPC, it is also a software-defined network environment, which is isolated with outside, or also isolated between different VPCs. So this is the feature of VPC. And also you can design your own network architecture and IP segmentation as you want without limited by the existing network design. This is a big advantage of VPC because as we know, if we are using the traditional data center or traditional network architecture, the IP address design or the IP segmentation is at a very big degree is decided by the existing IP address design, right? You should design your own IP address according to the IP segment that provided by the customer or provided by the data center. But if you are using the VPC on the Alibaba Cloud, you don't have to care about this kind of limitation because the VPC is a software defined network environment, and you can design your own network segmentation as you want in the VPC without affecting by some other elements. So this is the big advantage of the VPC. And for VPC, there are two important components that are inside of it. The first one is the vSwitch. Actually, the vSwitch is the same function as the traditional switch. It is used to provide the connectivity for cloud services. Like ECS, RDS is just like the switches. The traditional switches can provide their two connectivity of the servers, right? And you can create multiple vSwitches for multiple IP subnet. This is easy to understanding because if you have design or architect your IP segmentation in different segmentation, you should create several vSwitch, and for each of the vSwitch, it will connect the host or the ECS instances in one network, in one subnet. And the next one is vRouter. And actually this vRouter is also act as the same function as the traditional router. And it is used to provide connectivity between different vSwitches, which means that, for example, you have create several vSwitches, and for all of the vSwitches, it should be connected to the vRouter, and then all the hosts, all the ECS instances can within these two vSwitches can communicate with each other through the vRouter. But there is a limitation for the vRouter is that there is just one vRouter in one VPC, which means you cannot manually create one more vRouter. There are just one vRouter on VPC, and the one router vRouter is automatically created when the VPC is created. This is the limitation of the vRouter. And also, just like the traditional router, there is also a routing table on the vRouter, and you can also configure or add new routes in the vRouter. Okay, and the next concept we'd like to introduce you is the EIP. The EIP, the full name for EIP is Elastic IP. This IP is used to provide an internet connection for ECS instance in the VPC. This is something like the NAT that I just introduced you. With EIP, the host outside of the VPC can visit the ECS instances via EIP, and also ECS in the VPC can visit the internet by NAT to EIP. So this is the bidirectional NATing from inside of the VPC to internet or from internet to the inside of the VPC. You can just use the EIP to do the communication. And also for EIP, it can be bonded with any ECS instances as required, but it can only be bonded with one ECS instances at one moment. For example, if you have one EIP at this moment, you can bond it in ECS1, and maybe in next moment you can unbound it and bound it the EIP on ECS2. This can be changed as your requirement. And after we talking about the EIP, I would like to give you an introduction about the NAT gateway. So what is the NAT gateway? NAT gateway is used to provide comprehensive NAT service for cloud services in the VPC. Because just now we are talking about the EIP can also provide the NAT service, right? It can provide the NAT from the outside to the inside or to the inside to outside. But for NAT gateway, it can provide a more powerful NAT service. NAT gateway need to be bounded with EIP when provide NAT service, which means the NAT gateway should be worked with EIP together. And I just mentioned that the NAT gateway is more powerful. So what is the more powerful point is that NAT gateway can provide SNAT to establish connection from VPC inside to internet, and at the same time it can also provide DNAT to establish connection from internet to VPC inside. These 2 points is actually the EIP also have these 2 points, but the DNAT of the NAT gateway can achieve multiple ECS instances share one EIP to provide services on multiple ports on one single EIP. Because just now we are talking about EIP, and one EIP can just bond with one ECS instance, right? If the EIP is bounded with some ECS instance, it cannot used by some other ECS instance. But in the NAT gateway, we are using the DNAT, and then in this feature it can achieve multiple instances share the one EIP. And so this is the advantage for NATing, that we can save the EIP resources. This is the advantage. Okay, so for this page is the detailed comparison between NAT gateway and EIP. First, we can say that the NAT gateway work together with EIP to provide a NAT service, and EIP can be bounded on ECS directly without using the NAT gateway to provide a NAT service. And the second point is that EIP can be used flexibility to provide SNAT and DNAT for multiple ECS instances. But for EIP, only one EIP can be bounded on one ECS instance. This is not that flexibly like the NAT gateway. Because when we are using NAT gateway, we can use it flexibly to map different internal VPC ECS instances in one single EIP. This is the difference. And the last point is that the EIP on the NAT gateway can share the same network bandwidth, because as we know that on Alibaba Cloud, the bandwidth resource is also expensive, or is also it will be also charged, right? And with NAT gateway, we can make it possible that all the EIP, maybe 10 EIP or 5 EIPs, will share the same network bandwidth. But if you are just using the EIP independently, each EIP can only have its own bandwidth. So this is, maybe we can say, this is the waste of the bandwidth resource. So this is the comparison between NAT gateway and the EIP. Okay, this is all the things about the switching and routing. Thank you. Bye bye. Hey guys, Welcome to Network Serial Courses from Alibaba Cloud. Today is the third course, and today's topic is about load balancing. So we get started. For the first section, we will learn about what is load balancing. In this section, we will have brief understanding about the load balancing service. So we move on. So firstly, we should know that how the load balancing device works. So load balancing is used to distribute workload into multiple business processing units. And the original purpose for load balancing is that we use load balancing to avoid work overload of one single business processing node. Because in the original business mode, we run our business just on one single node. So in this way, there will be a performance bottleneck, right? Because the performance is limited for one single business processing node. So in order to expand our business ability, we will introduce multiple business processing node to deal with our business. So in this scenario, we need a device to distribute the business request. So that's why we are going to use the load balancer. And then when we can use load balancer by using multiple components with load balancing instead of a single component. In this way, it can increase reliability and availability through the redundancy. Because when we are using the load balancing, we will have several business processing units to process the business at the same time. And then in this way, even one single business processing unit is down, and the rest of them can continue to provide the service. So in this way, we can achieve the service redundancy. And when we are talking about the load balancer, usually a load balancer involves dedicated software or hardware. So which means that if you want to achieve load balancing function, you can achieve it with software or with dedicated hardware. Okay. So when we are talking about load balancing, there are two kinds of load balancing services that we should know. They are layer 4 load balancing and layer 7 load balancing. Here is the comparison for both of these two kinds of load balancing service. Here we can see the layer 4 load balancing first. For layer 4 load balancing, it distributes workload in OSI layer 4, which means it's the TCP IP layer. But for layer 7, it distributed the workload in OSI layer 7, which is the application layer. So this is the difference. And for layer 4, the backend unit is located in IP and port, which means when you want to add a backend business processing unit behind the load balancing, and you should define the backend processing unit with IP plus port in this way. But in layer 7, you not only you should provide the IP and port, but you will also provide what kind of application content will distribute it to the specified business processing unit. This is the difference. And the last point is that when you running the load balancing on layer 4, you don't have to care about what kind of application which is running above, because in layer 4 there is nothing about the application content, right? But when you want to do the load balancing on layer 7, it is mattered that what kind of application you want to do the load balancing, because some of the application maybe is using the protocol that is very special and is not supported by the load balancer. So when we are using the layer 7 load balancing, we should know what kind of protocol the application is using. For example, is HTTP or HTTPS or some other special protocol that is not widely used. So here we can say if your application are using some special protocol, or you are using some special application, and it is suggested that you use the layer 4 load balancing. Otherwise, if you are using some common used protocol like HTTP or HTTPS, and you can use the layer 7 load balancing. Okay, so this is the difference between these two kinds of load balancing service. Okay, after we have known briefly what is load balancing, so for the second section, we will learn about some concept about the load balancing. So let's go on. The first one I'd like to introduce you guys is the VIP. VIP, the full name is virtual IP. So for VIP, it acts as the unique IP entry point of a load balancing application. Here we can see that the virtual IP is in the entry point of the whole system, which means that the client from outside, if the client from outside will want to visit the application, it should visit the VIP first, and then the VIP will receive the request from the client and then distribute the request to the backend application. So this is how the VIP works. And then the next one is that the VIP normally located on the load balancing device. It is not located on the application side. It is located in the front end. So it is located on the load balancer device. And then the last point is that multiple VIP is supported on one load balancer for multiple applications. This is actually, we can see this is an obvious thing, because for one load balancer, at most of the time it will not responsible for only one application. Maybe on the back end there are several kinds of applications, like web application and business processing application, different kinds of application. So on the front end, we should provide different VIP or virtual IP for different application cluster. So this is how VIP works. And the next concept for load balancing we'd like to know is the session sticky. So what is session sticky? We can get it with this comparison from this picture. Here we can see the left side. If we don't use the session sticky, which means that all the requests from outside will be distributed into all backend servers in average, and it will disregard the source client IP or source client host of each request, which means we can give an example. All the requests from web browser number 1 and will be distributed to all the backend servers for server 1, 2, 3. And the request from the web browser number 2 will also distributed to all the backend servers. This is the how it works if you don't use the session sticky. And if you are using session sticky, what it will be, we can see the picture on the right side. If we have enabled the session sticky, the request from one single source client or one single source IP will be distributed to the same backend server, which means that all the requests from web browser number 1 will be distributed on only one backend server, maybe server 1 or server 2. And also for web browser number 2, all the requests from it will also distributed only on one backend server. So in this way, we can guarantee that the session consistency from one source client, because for some scenario, if we don't enable the session sticky, especially the website, if we don't enable the session sticky, there will be a result that when you visit the website, you will see some incomplete part in your website. So this is why we want to enable the session sticky to guarantee that the session consistency from one source client. Okay. The next one that we should know is that when we're doing the load balancing, the business request distribution, we have 3 different kinds of distribution policies or rules to decide how the load balancer will distribute the business request. The first mode is the round robin mode. In this mode, actually this is the default mode by most of the load balancer, is that all the requests from outside will be distributed into the backend servers in average. Means all the backend servers in the backend will have the same opportunity to be distributed the business request from outside. This is the default mode of the load balancer. And the second one is the weighted round robin mode. In this mode, there will be a weight configured on each of the backend server. For each of the backend server, we will configure a weight value on it. And server with higher weight value will be distributed more business requests. And normally servers with higher specification will be configured higher weight value. I think this is easy to understanding, because for the first type of the load balancer, the round robin mode, this default round robin mode is used when all the backend server have the same hardware specification. But there are some scenarios that not some of the backend server have higher hardware performance, and some of them will have a lower hardware specification. In this scenario, we should make the servers with higher specification take responsibility for more business requests, right? So this is easy to understand. We should set the higher weight value for the more powerful server and make it to take more business requests. And then the last mode is the least connection mode. In this mode, server with least connections at current moment will have higher opportunity or high probability to be distributed the business request. In this way, the connection quantity of each of the backend server will be taken in consideration. If now, for example, if now server 1 have 5 connection and server 2 just have 1 connection, then the upcoming business request will be distributed to server 2 in a higher opportunity. So this is 3 different kinds of load balancer distribution policy. Okay, so the next concept I'd like to introduce you is the health checking. So firstly, we should know that what a health checking is for. So here, health checking is aimed to check the working status of the backend server. So maybe you will ask why we should check the working status of the backend servers. Let's, for example, if now the one of the backend server, for example, the server A, is not working normally, which means that this server cannot process the business request normally. In this way, if the load balancer doesn't know, then the load balancer will continue to distribute the business request to the server A, right? So in this way, we will find that some of the business request which has been distributed in server A will be abnormal. So this will affect the normal running business. So under this situation, we should use the health checking to make sure that all the backend servers should be in the normal working status. Okay. And the next one is that if one server was marked as failed status in the health checking, it will not be distributed the business request. So this is easy to understand. A failed server should not continue to receive the business request. And then the last part is that if the failed server recovered after the failure was fixed, and then the server will be marked as healthy again, and then the load balancer will continue to distribute the business request to the recovered server. So this is how the health checking works. Okay, after we have learned something about the load balancing concept, and for the third section, we will learn some common adopted load balancing solutions. So how can we achieve the load balancing? So let's move on. The first widely used load balancing solution is based on the hardware. So in this solution, the load balancer entity is a hardware device. And normally, dual machine is required for redundancy because for load balancing itself, we should guarantee the service redundancy for the load balancing. And hardware load balancing can provide stable and high performance load balancing. Actually, this one is compared with some other open source software based load balancing solution. And hardware load balancing normally is very actually we can see it's very expensive because hardware is load balancing. We have say that it has provide stable and high performance. So at most of the time, hardware load balancing is using some special or dedicated industry level hardware. So it is expensive. And for hardware load balancing solution, there are some well-known brands like F5 and ReadWare. So this is the hardware-based load balancing solution. And the next load balancing solution is the software-based load balancing. And for this kind of load balancing solution, the load balancer entity is a software deployed on the servers. So it's not a dedicated hardware. And then normally dual machine or dual server is required to configure HA mode of the load balancer for redundancy. Actually, for this one is the same with the hardware solution. Both of them we should configure the dual node to make sure that it will have a high availability protection. And the third one is that the software based load balancing can provide various kinds of load balancing features. Like for most of the load balancer software load balancing, it can provide the database distribution load balancing. So this is what most of the hardware load balancer don't have, because for hardware load balancer, maybe they can provide a stable or a high performance load balancing service, but just for basic load balancing features. For some of the high level or application level load balancing or some special protocol, normally they don't have very good support. And the next one is that flexibly deployment on the servers, and the servers are more cheaper than hardware load balancing. So this is the advantage compared the software-based load balancing with the hardware load balancing, is that the software, because it is a software, so you can deploy the software and any we can say operating system on any of the servers instead of buying the dedicated server or prepare dedicated hardware to deploy the load balancing service. And also for software-based load balancing, there are also many well-known software load balancing solutions like LVS or like HA proxy and Nginx. So these three kinds of software is the most, actually we can say the most famous load balancing software in the world. Okay, so after we have learned something about the load balancing and also some common load balancing concept and the solutions, so for the last part, I'd like to introduce you the Alibaba Cloud load balancing solution, which is the SLB. So we move on. Okay, so we were talking about SLB. And the full name for SLB is Server Load Balancer. This is the name, actually is the meaning of the SLB. And for SLB, it is the software-defined load balancer service from Alibaba Cloud based on LVS and Changing. And the SLB will distribute the incoming traffic to multiple elastic computing service, which is the ECS instances, according to the configured forwarding rules. So this is something same with the traditional or normal load balancer, is that is used to receive the incoming traffic and then distribute it to the backend servers. And just now I just said that the SLB is based on LVS and changing. Here is introduction about this one is that LVS is for layer 4 load balancing and the changing is for layer 7 load balancing. So this is how the LVS and the changing works for SLB. Here from the picture on the right side, we can see that for different zones and for each of the zone, we have LVS cluster and changing cluster for layer 4 and layer 7 load balancing, and LVS and the changing will work together to provide a comprehensive load balancing services for SLB. Okay, so after we have learned what is SLB, and then in this picture we will see that how the SLB can achieve high availability. So first one is that SLB can support distributed traffic to ECS instances across multiple zones in one region. So this is a big advantage because if the ECSs in one zone, all the ECSs in one zone is crashed, it doesn't matter because the SLB can distribute the traffic to the remaining ECSs in another zone. So this is the SLB. One of the SLB function that they can achieve high availability for the services that are running in the backend. And for the SLB itself, just like the traditional load balancer, or no matter it's hardware or software, SLB itself can support to work in HA mode and to have active and standby SLB instances in two zones. Here we can see the picture on the right side. In this picture, there are two SLB instances on two different zones. Actually, these two SLB instances is working in active and standby mode. And if the primary zone failed or the SLB instances on the primary zone failed, the SLB service will switch over to the standby instances on the backup zone and without affecting the SLB service. So this is how the SLB itself achieve the load balancer. Achieve the high availability. And then for the backend ECS servers, the remaining ECS instances in the remaining zones will also continue to process the business. So on the load balancer layer and on the backend ECS instance layer, we can use the SLB to achieve the high availability. Okay. After we have learned that the SLB can achieve high availability for service or for itself, in this picture we will learn that SLB can also achieve disaster recovery function. So here from this page we will know that combined with Cloud DNS service from Alibaba Cloud, SLB can achieve disaster recovery function, and the business will be deployed across multiple regions with different public IP address on SLB for each region in this scenario. And DNS will provide a unique domain name as the unique service interest point and make resolution to multiple public IP addresses. This point is different from the HA because in the previous slide we know that the SLB is the unique interest of your service because all the ECS instances is behind the SLB service. So SLB is the unique interest, and all the data flow will go inside from the SLB and then distributed to the backend ECS instance. In this disaster recovery scenario, we should have a higher level of the service interest which is higher than the load balancer. So DNS will be acted as this role. So DNS will provide a domain name, and this domain name will corresponding to the both of the public IP on the SLB on both of the region. And once one whole region is failed, or once the SLB service on the one region is failed, the DNS will make the public IP on the remaining region, or we can say on the standby region, as the resolution IP. And then in this way, we can achieve the disaster recovery switch over, because previously the data flow is mapped to the primary site. After the primary site is done, then by using the DNS resolution, we can change the resolution IP from the previous one to the standby one, and then during the IP resolution switchover, and we have finished the disaster recovery switchover. So this is how the SLB works for disaster recovery. Okay, so from the previous slides, we have known that the health checking feature is a very important load balancing feature for load balancing. And then in the SLB part, we will learn about that how can the SLB do the health checking. So here we can say that the SLB support TCP UDP health checking for layer 4 and HTTP health checking for layer 7. So this is how the supported health checking mode for SLB. And the next one is that the TCP health checking is based on the TCP 3 steps health checking procedure. So with the 3 steps health checking for TCP protocol, and we can check whether the backend server can establish the TCP connection normally, and then we can know the status of the backend instances. And for UDP health check is based on the UDP propping message, just like when we are using the ping to send the ICMP package, and to check whether the backend ECS instances can respond the normal message to the SLB instance. If we cannot get the response message, and which means that the backend ECS instances is unreachable, then we can know that the backend ECS server is not working normally. Okay, and for the HTTP health checking is based on the HTTP head request and response procedure. So in this health checking, the SLB instance will send the SLB head request, and the backend ECS will respond the status code. If the status code is normal, like if we are running the HTTP web server, and then the response status code should be 200. And if it has response the status codes like 404 or 503, this kind of abnormal status code means that the backend ECS instance is not working normally. So this is how the HTTP health checking is working. Okay. So after we have talking about the features previously, and actually we can see that these features, most of the features is also existed in the traditional hardware-based load balancer. So in this page, there is a feature, or we can see the advantage that the SLB have, but the traditional load balancer don't have, is that SLB have the security protection that provided by Alibaba Cloud. Since SLB will provide service on internet, so Alibaba Cloud will provide anti-DDoS protection on SLB, which means any DDoS detection on the internet IP address on the SLB will be protected by the Alibaba Cloud. And then, just like all the internet services on the Alibaba Cloud, like ECS or RDS, and the basic anti-DDoS protection from the Alibaba Cloud can protect the SLB from DDoS attack under 5 GB per second. This amount of DDoS attack can be protected. So this is the big advantage compared with the traditional hardware-based load balancer. Okay, so all the above is everything about the SLB. Thank you. Bye bye. Hey guys, welcome to Network Zero courses from Alibaba Cloud. So today is the fourth course and today's topic is about the network security. So let's get started. So for the first section of today's course, we're going to learn about the network security concept. Here we will learn something common used in the network scope. What is the common used concept that is widely used in the network industry? Okay, so for the first one, what we are going to learn about is a firewall. Because when we are talking about network security, the first thing that we will remind is the firewall. Firstly, we should know that what is firewall. Firewall is the safety guard of your internal business network. And firewall is used to monitor and to control incoming and outgoing network traffic based on the predetermined security rules. Here it says the incoming and outgoing, which means that the flow control from network is bi-direction, from outside to inside and also from inside to outside. You can control with firewall. And then firewall can be hardware devices, like the devices from some security vendors like Juniper or Checkpoint, or also can be software-defined solution, like the software deployed on Linux, like IP tables or FireOD, this kind of software firewall that in Linux platform. And for the last point is that firewall normally deployed at the edge of your internal network. If we say that the firewall is just like the guard of our home, right? Because sometimes we can say that the internal system of our company is our home, and the firewall is just like the guard of our home. So it's easy to understanding that why firewall should be at the edge of your internet network, because the firewall should function as a protector of your system. So it should be at the outer edge of your IT system. And after we have talked about the firewall, there is another concept that we have to mention about is the DMZ. The full name for DMZ is demilitarized zone. And what is DMZ? DMZ is a network area between the trust zone and the untrust zone in the traditional firewall definition. So here is there's two new concepts, the trust zone and the untrust zone. So what is trust zone? Actually, roughly we can say that trust zone is the internal network area for your own company or for your own enterprise. And untrust zone is what? We can just briefly understanding trust zone is the internet, which is the network area that not belongs to your own company or your own enterprise. This area we call it untrust zone. And the DMZ is the area between the trust zone and untrust zone. So and that's the thing is that how can we use the DMZ? So here we can say that normally DMZ is used to deploy the internet web service or the internet reverse proxy for internal web service. So here we can just define that DMZ is used to deploy some application that belongs to your internal network, but will provide internet service to outside. So this kind of application will be deployed on the DMZ. It is not a pure internal application, but it will also provide the internet service. So this kind of application we can be deployed in the DMZ. And for the last point is that for best practice, when we're configuring the firewall and the DMZ, we will set the policy like that. Untrust zone can only visit the DMZ zone because sometimes we will consider that the untrust zone is not safe, right? So the DMZ is this kind of area that receive the access from the trust zone, and then the DMZ can visit the internal network because after all, DMZ is the system that belongs to your internal system, right? And then so we can control the policy like this: the untrust zone visits the DMZ zone, and the DMZ zone visits the internal network, it visits the trust zone. But we cannot let the untrust zone to visit the trust zone directly. So this is the best practice when you design the firewall policies. And just now we have mentioned the firewall policies, right? So in this page we will have a detailed understanding about firewall policy rules. So what is firewall policy rules? It is used to control the access between different zones or between different hosts. And normally firewall policies rules consist of those elements. First one is the source IP, which means that where your connection from, and the destination IP and the destination port means that where your connection want to go, and the protocol means that what kind of application your connection is running, and then the last one is the action, means that for this rule it will allow your connection go inside, or it will forbid your connection. So all these elements consist of one firewall policy rules. And the next one is that, which is also very important, is that the firewall policy rules are sequence sensitive. What does it mean? It means that each incoming connection will match the policy from up to bottom. It is very important. And the first matched policy will be adopted, and the rest of the policies in the bottom or in the rest of the policies will be ignored. For example, if there are some connection, it has matched the first rule in your rule list, and then the first rule is permit this connection, then the connection will be permitted, and then it will go inside of your system. Even though there is another policies rules in the coming or in the below, and then it will be ignored because we just mentioned that the policy rules is sequence sensitive. It will match the first policies that it matches, and so with this principle, for best practice, we will put the last policies as the all delay policies in case of any unknown incoming traffic, because there is some scenarios that for some of the connection there is no policies defined in the policy rule list. So in this scenario, we prefer to delay this kind of unknown incoming traffic, which is not predefined in our list, to make the security of our system. So this is how the firewall policy rules works. Okay, when talking about the network security, there is an attack that we must mention about, is the DOS attack and the DDoS attack. So firstly, let me see what is DOS attack. The DOS attack, the full name for DOS is a denial of service attack. So this kind of attack will send data flood to target machine, to attempt to overload target machine and make a legal visit unavailable. So with the data flood, and then it will make the target server overload, and then in this scenario, the legal visitor will see that the server or service is not available, but actually the reason is that all the resources has been occupied by the DOS attack. So this is how the DOS attack works. And but normally for DOS attack, normally it just have only one or a few attackers' machines will be used. So for DOS attack, it is easy to block because the attacker is just one or a few. So it is easy to just block the IP address of the attacker. Then you can protect your server from being attacked, right? But there is another kind of attack named the DDoS attack. Actually, we can say that the DDoS attack is the advanced version of DOS attack. And the DDoS is the distributed denial of service attack. So with the DDoS attack, there will be an attack controller. The controller maybe just have one, but the controller can control a big amount of zombie machine. The zombie machine is the real attacker that attacked your system. It will control the big amount of the zombie machines to send data flood to targeted machine and attempt to overload the targeted machine and make the legal visit unavailable. So the difference between the DDoS and the DOS is that the DDoS will have a big amount of attackers. Just now we are talking about that the DDoS is easy to block, right? Because there are just several IPs that are attacking your system. But for DDoS, it's very hard to block because there is thousands or 10,000s of the attackers that are attacking your system at the same time. So you cannot block this big amount of IPs so fast. Sometimes we say that DDoS is much more dangerous than the DOS, and also a very big security threat in the current internet environment. Okay, after we have learned something about the security concept, and for the second section, we will learn some typical traditional network security solutions. And from these solutions, we can say how can we design our system to protect our system from the security issues. So let's move on. For the first one is the 3 layers of application architecture. With this architecture, our system will be separated into 3 layers. And for the upper layer is the presentation layer. Presentation layer will be for web service, which provide a user interface to end user for use. At most of time, web server or this presentation layer also provide the service to the internet. And then the middle layer is the business layer. The business layer is used for backend business processing service, which will receive the business request from the web server or from the presentation layer, and then finish the real business processing. So this layer is the most important layer, who will deal with most of the business logic. And then the lowest layer is the data layer. So this layer will use for data storage. And most of the time, database will be located on this layer to do data storage. And then in this architecture, there will be a firewall between each nearby 2 layers to control access. For example, the presentation layer and the business layer, between these 2 layers will be a firewall. And also for business layer and the data layer, there will also be a firewall between them. So with this architecture, we can make sure that any one layer will not be affected by another layer that is protected by the firewall. Even, for example, even the web server on the presentation layer is attacked or has been accessed by some malicious visitor, and then there are also a firewall that has isolated the presentation layer with the business layer. Then we can protect the business layer from being attacked by the outside. So this is the architecture for the 3 layers of application. Okay, so for this page is another protection method that can protect our system. Previously, we have introduced you that we can use the firewall to protect our system, right? But the function for firewall is very limited, and most of the basic firewalls can just set some firewall policy rules. But if the system is attacked by the like DDoS or like some other malicious access, the firewall can do just the little things. So in this scenario, we will use the IDS and IPS to protect our system. So here we will see what is IDS and what is IPS. So IDS, the full name for IDS is Intrusion Detection System. And for IPS, the full name is Intrusion Prevention System. So from the full name, we can tell the difference. For IDS, it will only detect the system intrusion and send alert to the management system, which means that it only do the detection. It will not do any protection action. And so here we can say no interfering on the data flow. It will let the data flow go inside, but it will just send the alert or alarming to tell the management system that maybe now there is a attack is happening. But for IPS, it's an advanced version of IDS. The IPS will block the intrusion flow and protect the system from being attacked. So this is the difference between IDS and IPS. Is that IDS just for alarming, just for the detection and alarming. But for IPS, after it has detected the intrusion attack, and it will protect, block the intrusion flow and protect the system. So that's the difference between IDS and IPS. But there is a same point for these two protection methods, is that these two features at most of the time will rely on hardware support. Sometimes you should expand your firewall or add some new card or some modules on your firewall to support this kind of features. Okay, and for this page, we will introduce you another data protection method for our system, which is we will use the SSL to do in data encryption when our data is transferring from the client to the server. And in this scenario, the client and server side will keep the public and private key pair, and then before the data is transferred, the data will be encrypted by the public key that kept in the client. And then when the data is transferring, then you don't have to worry about that the data maybe will be captured by some bad guys or stolen, since the data has been encrypted by the public key. Even somebody has captured your data, they cannot get the information inside of it because the information has been transferred during the encryption procedure. And then after the data has arrived at the destination, the data will be decrypted after arriving at the destination with the private key kept on the server side. So with this algorithm, we can achieve that the data transferring is encrypted, and you don't have to worry about the data will be captured in the middle of the transferring. So this is how the SSL encryption protect our data. Okay, and the next solution for security is the Jump server. I'd like to introduce to you. So what is Jump server? So briefly speaking, we can say that Jump server is used to access and manage the internal business system from the internet. Because there is a scenario is like this. For example, in your internal business system, you will have maybe 10 or 20 or 100 servers that should be managed, but you don't want all the servers can be accessed from the internet, right? So in this scenario, we will have the Jump server, and then in this scenario, we can just access the Jump server from the internet, and then from the Jump server, we can access all the rest of the servers in the internal network. So this is how the Jump server works. And normally, Jump server is located inside of the system behind the firewall. So there is a network area that is very suitable for jump server is the DMZ that I have introduced you previously, because jump server is this kind of business that it is a member of the internal system, but it will provide the internet access service. So this kind of server, we can put it in the DMZ, just like jump server. And then besides the basic jump server function, we can use the jump server to manage the rest of the system. And jump server normally have more functions, like we can use jump server to do the access auditing. You can from the jump server you can know that who and when has accessed the system from the jump server. And also you can create some users and give some rules and privileges to control the access from the jump server. And then also, just like some other security solutions, jump server may serve as independent hardware or just the software deployed on server. So this is just like the firewall. You can use the dedicated hardware solution, and also you can use the software solution to deploy it on some of the servers in your internal network. So this is how jump server works. Okay, after we have learned about the common used traditional network security solution and also some common used security concept, so for the last section, I'd like to introduce you the Alibaba Cloud Network Security Solutions. How the Alibaba Cloud will protect the cloud environment with its security solution. So let's get started. The first cloud network security from Alibaba Cloud is the security group. So what is security group? Maybe you will ask. So here we can just briefly say that a security group is acting as the firewall inside of the VPC or on the cloud, which means that we can use the security group to control the access policy between the cloud services instances within one VPC. For example, within one VPC we have some of the ECS instances that is running web application, and some of other ECS instances that is running on business processing application, and then we can put these two kinds of ECS instances on different security group and set the access policies. For example, from which IP address you can visit the service, which port on the security group. Then in this way, we can use the security group to control the network access policy. And then another thing is that instances in one security group is just like located in one zone in the firewall definition. So this is the comparison between the security group and the firewall. There are something same with the traditional firewall. And then the last point is that you can configure access policy for each security group to allow specific IP address to visit a specific port of your security group. So this is the basic function of the security. Also is the major function of the security group, right? To do the IP access control. So this is how the security group works. Okay, so for this page is the next security solution that is provided by Alibaba Cloud, which is the anti-DDoS service. Actually, previously we have introduced you anti-DDoS in the SLB part, right? When the SLB is providing the internet service, by default it is protected by the anti-DDoS basic version. But we should know that the anti-DDoS is also have the professional version. So here we can say the difference between the basic version and the professional version. So here we can say that the anti-DDoS basic version can provide protection on the cloud system from DDoS attack under 5 GB per second. But if your system is attacked by a much higher amount of data, which is much more than 5 GB per second, you should use the professional version because the professional version can provide a protection for your cloud system from DDoS attack up to 20 GB per second to 300 GB per second. This big amount of data attack can be protected by the professional version. So this is the big advantage of professional version compared with the basic version. And the second one is that for the basic version, it can support multiple attack type like ICMP flood, UDP flood, TCP flood, S1C flood, ACK flood. But for professional version, it can provide more attack type than the basic version. So this is also an advantage. And the last point is that the DDoS system for the basic version of the anti-DDoS is located in the same data center with the Alibaba Cloud. There will be some individual servers that are used to do the anti-DDoS function for the basic version. But for the professional version, the DDoS system is located in the dedicated data center, which is different from the basic version. And as we know that a dedicated data center will have a more powerful data washing ability than the just several servers for the basic version, right? So here we can say overall the professional version of the anti-DDoS service have a more powerful ability of anti-DDoS than the basic version. Okay. So the last security solution from Alibaba Cloud I'd like to introduce to you is the Alibaba Cloud SSL certificate service. With this service, it allows customers to directly apply, purchase, and manage SSL certificates on the Alibaba Cloud. And you don't have to manage it by yourself. There will be a unified service used to manage it, right? And then Alibaba Cloud SSL certificate service can incorporate with qualified certificate authorities. So you don't have to worry about whether the certificate is a good one or is a formal one or is a certificate one. You don't have to care about these issues. The Alibaba Cloud will cooperate with the qualified certificate authorities to make sure that we are using a qualified service. And then here we have some benefit from the certificate service. Is that the first one is easy to use. Because for this service, it can manage digital certificates on a unified platform. You don't have to contact each of different certificate vendors to apply the certificates. You just need to use this unified platform to manage your certificates. And the second one is the security. This platform allows customers to directly apply, purchase, and manage SSL certificates on Alibaba Cloud. Okay. And the next one is scalability. It means that this platform can offer in cooperation with qualified certificate authorities. It's just what I have introduced you previously, which means that you have more choices to apply that certificate. Not only one vendors you can apply. You can apply from multiple vendors, and but all the vendors is qualified vendors, and you can apply your certificate from different qualified vendors. So this is the advantages of the Alibaba Cloud SSL certificate services. Okay, so this is all the things about the network security content. Thank you for listening. Bye bye.